All right. Welcome to podcast 1.3. All right. So, in this podcast, we are going to be talking about the different types of matter. All right. So, our first kind of type of matter that we'll be talking about is going to be a pure substance. So, this is going to be a substance that cannot be separated by physical means. So, our kind of subcategories for this is going to be an element and a compound. So our element is going to be a pure substance that cannot be broken down by physical or chemical means. So these are going to be the ones that we find on the periodic table. So this is going to be like our oxygen, nitrogen, carbon. All of those are going to be elements, and they're going to be considered a pure substance. Next is going to be our compound. This is also going to be a pure substance, but this is just going to be when two or more elements that are chemically combined. And so, kind of like the common example is going to be carbon dioxide. So, what we breathe out is going to be a compound, so CO2, and that is going to be a pure substance. All right, our other types is going to be our mixture. And this is going to be a combination of two or more pure substances in which each retain their individual properties. So this is going to be the idea of mixing like salt and pepper. So you're able to mix salt and pepper as much as you want, but they're going to retain their individual properties. So our salt is still going to taste like our salt, and our pepper is still going to taste like pepper, no matter how much we mix them. Now, we have two subcategories of mixtures. Our first is going to be our heterogeneous mixture. And this is going to be when a mixture that does not mix evenly. And this is going to be when you can see the individual parts. And so the kind of nice example for a heterogeneous mixture is going to be like a pizza. So a pizza is a mixture, and it's specifically going to be a heterogeneous mixture. And that's going to be because we're able to see those individual parts. We're able to see the bread. We're able to see the sauce. We're able to see the cheese. We're able to see all of those individual parts, no matter how much they're mixed up. Next is going to be our homogeneous mixture. And most often in chemistry, we call this a solution, just because it's going to be a liquid. And this is going to be a mixture that does not, or sorry, a mixture that does mix evenly. All right, so this is going to be when we cannot see the individual parts. And so a good example of a homogeneous mixture or solution is going to be salt water. So whenever we dissolve salt in our water, it becomes a homogeneous mixture. We're not able to see those individual salt particles in our water. And then our next one is actually going to be an alloy, not allow. So that was my bad. I will make sure to get that fixed. But an alloy is going to be a special mixture of metals. And the reason that we have alloys is to enhance different properties of metals. And one of the best examples of this is actually going to be rings. So if you have a gold ring, it is most likely an 18 karat gold. And what the 18 karat gold means is that it is mixed with another metal. And we mix metals together in order to typically enhance their strength. So if we had a pure gold ring, if we hit it against something, it would crush and break. But if we mix it with other metals, it becomes stronger and we're able to wear it longer. So that's going to be where our alloys really come into play. And so just in case, our alloy is spelled Ralloy. Just in case, I will get that fixed. All right, so our different separation methods. So most of the time, our separation methods are able to separate mixtures primarily. So our first is going to be our decanting. Second will be distillation. Third will be chromatography. And our fourth will be filtration. Now, there are a lot of different separation methods that are out there. So, if you do kind of like a quick Google search of different separation methods, you'll probably find that there are a lot more than the four that are listed. These are going to be the four that we are going to typically use in this class, though. All right, so kind of going over decanting first. This is going to be a separation of a solid and liquid by pouring out the liquid. So this is kind of be like if we have rocks and water in a bucket and we want to get rid of the water, we're just going to pour that water out, leaving those rocks at the bottom. So this picture right here is a pretty good example, especially for a chemistry. So a lot of times we'll have what we call a sediment, which will just be a solid, and then on top is going to be a liquid. And all we have to do is just pour out that liquid while leaving that solid at the bottom. All right, next is going to be our distillation. And this is going to be the separation of two liquids based on their boiling point. And so what we have is actually this distillation apparatus. They are really pretty expensive. However, we are probably going to use a kind of cheaper method when doing it in class, just so that we're able to make sure that we're able to, so that everyone's able to do it. All right, so the best example of distillation is going to be if you have a mixture of water and alcohol. So that kind of mixture you're able to separate based on boiling point. So alcohol is able to boil at a really low temperature. And so by just heating up a mixture of water and alcohol and heating it up, your alcohol is going to boil out first, just leaving the water behind. All right, next is going to be our chromatography. And this is going to be a procedure that separates a mixtures of individual molecule types. And most often we'll see this that it will separate based on color. And you're able to actually do this with your pen or like a marker. You're able to get like a solution, you're able to make a mark on a filter paper, and you're able to basically stick that in a liquid and it's going to separate all the colors that make up that pen. So our black pens are most often a mixture of a lot of different colors all together. And we'll talk about this one a little bit more in depth in class. All right, and then our filtration. So filtration is going to be the separation of a solid and liquid using a special filter paper. So if anyone has ever made coffee before, you know that there is a special coffee filter, and this is the exact same thing, is that you have a filter, in which case it's going to filter out essentially the solid, allowing the liquid to fall down. All right, and then kind of our next question on our packet is how many naturally occurring elements are there on Earth? So elements 1 through 92, except for elements 43 and 61, will occur naturally on Earth, although some are only present in extremely small quantities. So yes, there are a lot of elements on the periodic table that are not found on Earth. And there's even more not found on Earth that we actually create ourselves. So there are artificial elements. And once we get into the periodic table, which will be next unit, we'll go a little bit more depth into that. All right, and then next on your packet is how are elements and compounds similar? How are they different? We'll talk about this a little bit more in class. I don't specifically have a slide over it. All right, and then the last little part for this podcast is going to be our matter flow chart. So at the very top, we have matter. It is able to be broken down, so into our pure substance and our mixture, And then those are able to be separated into our even more subgroups. So a pure substance can be an element or a compound. A mixture can be heterogeneous or homogeneous. All right. And then I'm going to go over one other thing really quick in this podcast, and this is going to be our indicators of a chemical change. So this is going to be found on worksheet 1A. This will be number 1. So this is going to be page 8 of the packet. All right, so indicators of a chemical change. So this is going to be an unexpected color change, light production, odor production, a temperature change that's unexpected, formation of a precipitate or a formation of a solid, and gas production. All right. I know that I listed 6 out here and there's only 4 spaces on the paper, but go ahead and write out all 6 because all 6 are going to be a really good indicator of a chemical change. And in class, we are going to go through each of these just to see what they look like. All right. And that is going to be the end of podcast 1.3. And we are going to work on worksheet 1A in class. So we'll work on all those together. But that is pretty much it.